Okay, Mary asks you to help her find a specific box. The height of the square base box should be 2 centimeters more than the side length of the square base. Mary wants to personalize the box. She changes the side length of the square base to x centimeters. What would the volume of the box be? For part B, if the volume of the box is 16 centimeters cubed, what should the side length of the square base be? Okay, well, if this is square base, okay, so the box's square base is dimensions of x, and the height, h, should be x plus 2, right? So the volume of the box, therefore, as a function of x, should be length times width times height, right? So this is the length, width, this is the height. So it's x times x plus 2. Okay? So in this case, whoops, this is going to give me x squared times x plus 2, right? V of x is x cubed plus 2x squared. Okay, so this is the volume of the box. So this is part A. Now for part B, if the volume of the box is 16 centimeters cubed, what should the side length of the square base be? I'm going to let the volume of the function v of x equals 16. So x cubed plus 2x squared is equal to 16. I'm going to move the 16 to the other side. X cubed plus 2x squared minus 16 is equal to 0. And then what you want to do here is you want to solve for this equation, right? So this is a polynomial. It's a cubic equation, and in order to do this, you should factor this out. And the easiest way to factor this out is we want to use remainder and factor theorem, right? So I'm going to use remainder and factor theorem. If I look at potential factors, right, you're looking at potential factors of the constant, so it's 16. So 1, 2, 4, 8, 16 divided by the factors of the coefficient. So I'm going to test some of these values out. So if I test some of these values out, you can find that f of 2 actually is equal to 0, right? So you can do this just by guessing and checking, right? So f of 2 is equal to 0. So in this case, x minus 2 is a factor. If x minus 2 is a factor, you can use synthetic division or long division to find the remaining factors. So I'm going to use synthetic division here. Just going to do it out here. Okay, so I'm going to put 2 up here, and then I'm going to write down each of my terms. So x cubed, x squared, x to the power 1, x to the power 0. So this is a coefficient of 1, this is 2, this is 0, this is negative 16. And then I'm going to bring down the first coefficient. You do 2 times 1, which is 2. You add the 2 together, so this is 4. 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 is 16. Negative 16 plus 16 is 0. So your coefficient is going to have the terms 1 degree less than the dividend. So x squared, x to the power 1, x to the power 0, the remainder, right? This is 0, by the way. Remainder 0 means it's a factor. And in this case, our quotient is going to be x squared plus 4x plus 8. You can attempt to factor this. In this case, this actually isn't factorable, so you can just leave it like this. So one of your values, x minus 2, the other value is x squared plus 4x plus 8, right? And this is basically your volume function. So this is another way you can write your volume function. If you set this equal to 0, therefore x is equal to 2, right? So if the side length of the square base is going to be 2 by 2, right, and the height should be basically 4. Okay, so because x plus 2, right? So the side length of the square base is going to be 2 centimeters.